Hello and welcome back. If you joined in the last video, I went through AWS, some of the services that it offered. We created a new free AWS account, talked through some of the free offerings that they have for the first year and some offerings throughout your account. So talked through some things about EC2 instances and databases and build pipelines, all kinds of fun stuff. So now that we've created our account, after a couple days it should be validated, so we're able to log in. And so today I have a few goals for us to go over. So today's goals, we're going to sign in to AWS and create some new IAM groups, some new users. We're going to generate a new SSH key. I'm going to create a new repository in CodeCommit. I'm going to clone that down to our local desktop, import into a new IntelliJ project, and then try to push that code out to our remote repository on AWS. So I'm going to break each one of these down as we go and go over step by step what each of them is. So don't worry if you don't understand some of this, we'll talk through it all. So the first piece, we're going to go ahead and get logged into AWS. So aws.amazon.com/console. In the top right is an orange button, sign into the console. If you click that, there's a place to put in your email address that you signed up to AWS with. And something here to note. So this says root user sign in. When you create a new AWS account, that account has root privileges. That means that they have absolute control over every service in AWS. And there's no way to limit that control. So you cannot limit what permissions the root account has. And so if your root account ever gets compromised, your entire AWS services is now open to whoever's compromised your account, which is very bad. And so what we're going to do is a best practice with AWS. This should be the only time we log in with the root account. From now on, we're going to make groups and user accounts to sign in as. And those groups and user accounts will have limited access to specific services that they would need to perform whatever it is that they need to do. So in AWS, the place that controls groups and permissions access is called IAM. So if you go to Find Services, type IAM, hit enter, you go to the IAM services. And here, it has a checklist of things to do when you first sign in. I'm going to go ahead and go over to groups and delete these guys. I was testing a few things out before recording just to make sure everything is working for us. So when you log in, you should see this on IAM. All right, so IAM is broken down to policies, groups, and users as the main core. There's also roles, which we might delve into a little bit later, but for now we don't need to worry about it. A role is sort of a temporary access you can give a user. So if a user needs to do some DevOps related tasks to some instances, you can assign a role to that user to temporarily grant them the access they need to perform those actions. So we won't need to worry about that quite yet, but we do need to look at are some policies that's available to us, and to create some groups, and then to create some users and assign them to the groups. So starting at the bottom, what are policies? Policy is a JSON document that specifies what permissions that policy would grant or deny a given user. Out of the box, AWS provides all of these policies that you can use however you want. You can also create your own policies if there's specific ones that you want to combine or to tweak, things like that. For now, we'll use all predefined policies. To give you a couple of examples, say EC2. So there's, if you type in EC2 at the top to filter, there's all of these policies that have something to do with EC2. We can expand to see what access it will give a user that has this policy. So for instance, EC2 full access would give the user that has this policy full access to the EC2 service, full access to auto scaling, full access to ELB, which is, I believe, elastic load balancing, some limited access to the IAM services. So if we were to assign the full access to a user, they would have the full access to EC2. There's also something like the EC2 read-only access. If we compare the two, the read-only access has limited access to EC2, so you only list and read EC2 instances. So I can go in and look at what it's doing, but I will not be able to write or create or do new things with those EC2 instances. I can just look at it and see what the health is, basically. So we can utilize these policies to limit access to users. All right. So there's a couple today that we're interested in, and we will show those. So if we look up admin, there's this administrator access policy. Excuse me. So anybody that has this admin access policy, it provides full access to AWS services and resources. All right, so it'll allow a user to pretty much use AWS however they want. So it's similar to the root account, right? So you can still do whatever you want in AWS if you have this policy, but the difference is if a user that has this policy is ever compromised, I can go in as a root account or another admin account and strip them of this policy, and they'll no longer have admin access. So we can have some safeguards with that, right? So we can go in and fix any issues that we might have if something's compromised. So this will be one policy that we will need today. The other one, since we will be creating a repository and checking our code and committing code, we are going to use CodeCommit. That is the sort of Git repository that's private within AWS. So we're going to create a user, a developer user, that would have access to CodeCommit. They're going to have full access to that service, which means they can create repos, read, write, push, all that fun stuff. They also have some of these other services in a limited fashion. For instance, SNS is Simple Notification Service, and it allows you to bind to different events and detect and have things trigger to notify you. For instance, you can have SNS have your phone number and send you a text message when certain events occur. So if you want to send a text message and receive a text message whenever you listen to an event on the master branch. So if anybody pushes to master, it'll notify you of that event. That way you can keep track on if you want to know what's happening with your code. So that's one example of why SNS would be listed in here. So with that said, there's a few ways to have policies be connected to users. You can connect policies directly to users. And that is technically possible. You might have some instances where you want to do that, but a better way to manage policies is to create groups. And a group, you can associate policies to that group, then associate users to that group, and then any user in that group would then have those policies. So this is a way to apply policies to groups of people. So that should hopefully make sense. And why do we want to do this rather than assigning a policy directly to a user, right? So groups are preferred because say you have 10 users, 10 developers on your team, and you've gone the route of assigning a policy to each developer. So say in your organization you wanted to change the permissions that your developer group has, or your group of developers has. Since they're each connected to their own policy, you have to go into each user and update that policy for that user. All right, so that can be tedious, it can be prone to issues, hard to maintain and manage. But if you create a group for that developer role, per se, and assign the policy to that group, then you can add whoever developers you want into those groups. And if you ever want to change the permissions for your developers as a whole, you would update the group, and those changes would be applied to all of those users in the group. So that way it's much easier to maintain and a lot less prone to issues. So with that said, we'll go over to groups. We'll create a new group. This will be an admin group. Next step. So here's all the policies we can associate to our new group. We'll choose the administrator access. Last screen, you can review your group that you're making. Looks good. So we'll create that group. So now we have a group. And while we're here, we'll go ahead and create the developer group. We could create the admin, create a user, associate it, log out, then log back in as that admin user to create new groups and new services and things like that. And going forward, we'll do that. So this should be, once again, the only time we will log in as the root account. But for now, we will go ahead and create a developer group. Developers, we make it plural. We will search for CodeCommit. We'll have full access to this group. Create group. Now I have two groups, a admin group and a developers group. All right. Next is users. We'll create two users. One will be an admin user and one will be a developer. Go to the top, add user, username. I'll create an admin user. So there's two types of access in general AWS provides, and those are down here. One is the console access, so you can log into the console as if you are a physical human user. So you would log in with the username, password, go do whatever it is you want to do. The second access is programmatic access. What this boils down to is, say you have a database layer and you have a EC2 layer, your web service layer, and you want those two things to communicate. You can actually create a user with programmatic access to allow that communication. So you can say this EC2 instance is this user, use this account to talk to these databases. And that's programmatic access. You're giving a service, or it could be a person. You can choose both of these for a user account. And give that type of access to different components of your infrastructure. That way everything can communicate with each other. You can limit access, grant access, different services to where you're, say your EC2 web server access can talk to your databases in one region, but not a different region. Things like that if you would like. So for this admin account, we're going to have console access. We have a couple options for passwords, an auto-generated password or a custom password where we can just type in whatever password we want. We'll have the auto-generated password. Seems fine for our needs. Our last option on this screen is whether the first time that user logs in, you want to have them reset their password. So this is useful if you're an administrator, you have a new user, new physical person joining your team. You go in, add them as a user, have an auto-generated password, have this checked so that when that person goes in and signs in for the first time with their auto-generated password, they can choose a new password that they would use from then on, right? For us, I'm gonna keep this unchecked. I'll just keep track of passwords myself on the side. An auto-generated password would probably be more secure, more random, more symbols, more secure than something I would create as a person. So next screen is permissions. So this has our groups that we've created, which we'll be using. But on top, there's a couple other options. If you have other users in your system already, you can copy from that user to your new user. So say it's kind of like a template, right? One developer usually has the same access as another developer with that same type of role in your company. So if you already have that templated out, you can copy those permissions straight over and copy all the policies and groups and all that fun stuff to that new onboarded user. Another option, I kind of already went through this a bit, you can go through and select specific policies to attach them directly to your user. So we'll go back to groups. Since we created an admin group, we'll select that. Go to the next screen. And I'll take a quick moment here to talk about tags. Tags is pretty widely used in AWS. Pretty much every service, everything you can do, you can create tags. And these are simply key value pairs. It's a way for you to manage users, manage services, filter on searching for things, stuff like that. So you can create any kind of tag that you want. So you can tag all your users as what role they have. So if I wanted to, I can do role developer, or this would be the admin, right? So admin. So then if I have all these different users and I've tagged them and kept up with that tagging for everybody, I can then filter and see what users has the role admin, and it'll tell me all my admins. All right, so for now, for these guys, I'm not going to create any tags. They're completely optional, so I won't worry about it today. So, review on everything we're making. We have a username, the type is auto-generated password, it will not reset, it will be in the admin group. Everything looks correct. We go ahead and create that user. And there you go. Here you can download a CSV. It's just a file that would have all their details. It has the username, password, all that kind of stuff. And here under password, you can actually look at the auto-generated password that it made for you. So I will copy that over to another screen. To take note of that. All right, close, and we made an admin account. So once again, if we wanted to, we can log out as a root, log back in as admin to create our developer user. But for now, we'll go ahead and add another user, give it a username. It'll have some access, auto-generated password. We won't worry about resetting the password. Again, I'll just keep track on my own on passwords. This time I'll choose the developers group, so it'll have access to CodeCommit. No tags, review, create user, and go ahead and copy this password over. And there we go. So at this point, we have two users, an admin user and a coder. The last piece of information that we actually need to log in as these users is the account ID number for our AWS account. So where you find that is all right. So we'll go back real quick to IAM and see where we are. There's two other recommendations that they give us. One is to create an IAM password policy. So you can set a policy to where, we'll just go to it real quick. I won't worry about this today. But you can basically enforce a policy for all of your users to conform to. So you can have passwords expire after so many days. You can enforce at least one uppercase letter, one lowercase letter, mix and match whatever kind of policy that you want. Minimum password length, you can make 20 if you want, right? Very strong password. But we won't worry about that. All of the passwords I'll be using, since it's just myself doing this, I'll use the auto-generated passwords, which are pretty secure anyways. So the other item, if we go back to IAM, is to activate MFA on my root account. So I won't be able to do this on screen because I'm using my phone to record with. But MFA, I'll explain real quick, is multi-factor authentication. So right now, to log into the root account, all I need is my username and password. If I have MFA, there's another layer of security to your root account. So usually on your phone, you can download Google Authenticator or another MFA client and sync it with your account, and whenever you go to that app in your phone, you'll have a 6-digit number that you can put in as part of your login to AWS to be able to log in. And that 6-digit number cycles every 30 seconds. So every 30 seconds, you'll have a new 6-digit number. And so if somebody compromises your email and password for your root account, and you have MFA activated on your account, then they still will not be able to log in unless they've also somehow gotten that 6-digit number at that point in time to log in with. So again, this is to secure your root account, since that is your keys to the kingdom, so to speak. And again, I would use Google Authenticator on my phone. I'm using my phone to record, so I will do this off screen, but it is fairly straightforward. You go to Manage MFA, continue security credentials. There's a section, you activate it, it gives you step-by-step how to do that and how to synchronize it with your device, and you can go through and do it that way. All right, so we will go back to our goals and see what we've done so far. So we created new IAM groups for our admin and developers. We created a new admin user and a dev user. The next item is to create a new SSH key. And real quick, I'll go ahead and sign out of my root account. I won't need this anymore. So this is a convenient step for me. Whenever you use Git and AWS, you can always just put in your username and password for every fetch and push that you want to make. That will work just fine. But since we'll be doing lots of those over and over and over again, another option is to use SSH. So the way SSH works is you have a tool on your computer to generate a pair of keys, a public key and a private key. The public key we can put on our user, our coder user, and then the private key we keep on our desktop. And then whenever we do a push or a fetch or a checkout, things that would reach out to the remote repository, it will send the private key with that request. And that private key it's not identical to the public key, but it sort of combines with the public key to see if you have access. So by doing that, we won't have to worry about username and password for our Git commands. All right, and I'll have a link to this in the description, but this is their tutorial on how to go about generating the key, associating it to a user, all that kind of stuff. So we'll go through here real quick. So we already have Git installed on my computer. You can just Google for Git install and it should be pretty straightforward. And we want to use this SSH keygen command to generate our SSH keys. So I will open up a command prompt here. Type SSH-keygen. It asks us where to save the file. So by default, whenever you have SSH installed, it goes to your user account and a .ssh directory. And then for us, it will be called ID_RSA. So the default location is fine for us. We can set a passphrase to our SSH. So that just means whenever we want to use our private key, we'd have to supply a password to use it. Since this is a convenience thing for us to not worry about passwords, we can just press enter and leave it blank. It'll prompt us to retype it a second time to make sure they match. Again, hit enter, and there you go. We now have an SSH key, public and private, that we can use. So if I go to my PC, C drive, users, myself, .ssh, we have these two files generated for us. ID RSA.pub is our public key. ID RSA is our private key. So what we need to do is upload our public key to our user. So the way we go about doing that is that we need to log back into AWS. We're going to log in as our coder user that we made. So we don't need to log in as a root anymore. We can log in as our coder account. So we will sign into console. And here it says we can sign in with our account ID that we copied earlier. Our username. Our password that was auto-generated for us. And there we go. So now we are logged in again as our coder. And I guess just to show you, if we go to EC2, we get a lot of "you're not authorized to do these things." So we don't even have read access to all this stuff. We don't even know how many running instances are operational right now in AWS. So we don't have any type of this access, which is good. It shows our policy is working correctly so far. So go back to the home screen. Top right, we'll click our account. And there's an option, I will show. Put myself back on here. We have a tab for AWS CodeCommit credentials. We can go here, and now we can upload the SSH public key. So in here we can paste in our public key. So if we go back to our directory, we need this guy. So we will open this with a text editor like Notepad. Copy this whole string. Paste it in here. Hit upload. Now it is uploaded to AWS for this user. Public key, as the name implies, is public. It doesn't really matter if it's shared with users or not. This is free information to anybody that needs to look at it. It's the private key they want to keep secure. Don't ever share your private key with anybody else. Otherwise, they would have access to whatever SSH access they need. So, next, what is next? All right, so we've created a new SSH key. We've associated that key to our user. So now I want to create a new repository. So go back into AWS. Go back to the dashboard. Make sure you go to CodeCommit. And since our user has the policy, we can have full access to CodeCommit. So the top right, again, I will move. And now we need to give our repository a name. We'll say AutoTrader. Say, I would give a description if there's a lot of repositories and we know what is what, but for us, very simple. So we will go ahead and say create. So now we have a repository in AWS. So there's two ways to connect. There's HTTPS, where you supply your username and password. There's also SSH, which uses your private key, matches that with your public key for your user to know if you have access or not. Since we made our SSH keys, we will use that. So expand, I'm on Windows, so expand Windows, and it gives you different links on how to do different things. But the piece that we're interested in is this line. So there's a copy button. This is the URL for our repository. This is where it lives within the ecosystem of AWS. So we can go back to our, so we'll figure out a place for this to live. We'll probably put this on our D drive. I think I have an AWS directory set up already. We'll go ahead and delete some of this old stuff I was playing around with before. So we will have our code live in this directory on our machine. So we can navigate there. It's empty now. So if I go ahead and copy this URL once again, go back, paste it in, hit enter, and so the first time you connect to a new machine, you have this message pop up. It says we haven't authorized or permitted our machine, our desktop, to connect to this remote server. So if we don't know if we trust this server, so say it's a random server out there that you looked up on the internet, it could have some viruses, some Trojans, things like that. So it won't allow you to connect to it unless you say you want to connect to it. So if you type yes, it will put this URL, this host, in your trusted list of hosts. So this is a one-time thing. And it looks like we have some permission issues to figure out. All right, so let's think through this. So let's see if we missed a step. So going back to their doc, I'm guessing I missed a step here somewhere. So we've uploaded to AWS. So it looks like we need this step. So if we go back to our directory, actually scratch that, we will use Sublime Text or Notepad or wherever editor you want. We will copy this string inside of here. We need this piece. So it looks like if we go back to AWS, go to our user, go back to our security credentials, go to our CodeCommit credentials, and we need this SSH key ID. So we will copy this, and paste it here. So next, this needs to be saved as config. So file, save as, config, in our .ssh directory, hit save. And we will retry our clone. All right, so with this message, no such file or directory. So our default that we generated was ID_RSA, I believe. So we can double check that. ID_RSA. Looks good. Try again. Third time is a charm. So we don't see any errors. We have a warning because we're cloning something in an empty directory, because it is an empty directory. So if we go here, it is indeed empty because we haven't added anything to our repository yet. We'll go ahead and go back to CodeCommit. We'll go here. And our repository is still empty, so everything so far looks pretty good. Let's look at our list of goals. Go ahead and close this. So we create a new repo and we're able to clone it now after some triaging. So we need to import our repo to a new IntelliJ project. So you can choose whatever IDE you prefer. Eclipse is a popular one. I like IntelliJ. It's one that I've gotten used to over the years. A lot of really good features, especially like the database features in it. You can do all of your Oracle database schemas and queries and everything within IntelliJ itself. So you can have your code and your database, everything all together, which is really nice. By doing that, you don't need SQL Developer or any other UI for your database stuff. So that alone is really valuable for me personally. So hopefully this will start up here soon. Apologies, I still have a bit of a cough I'm trying to get over. One of the reasons I haven't been able to record in a while, but got some water, so. And it's on the other screen, but it's just booting up IntelliJ. Taking a while. I'll pull this over here. All right. So here, as if I'm really lagging at the moment. We'll pause and restart this real quick. Hello? All right. Looks like we are back. So, IntelliJ, this would be as if you just installed IntelliJ for the first time and you haven't created any projects or imported any projects, so you don't have any listed. So here, create new project. There are a variety of types of projects you can create with IntelliJ. We will choose Maven. Maven and Gradle are similar. They're both, build tools and dependency management. So Maven uses POMs. So if you hear somebody say, "What's your POM look like?" That's a Maven file. And in your POM, you say what your jar looks like, how you package it. Do you package it as a jar? Do you package it as a WAR file? How is it named? It lists all your dependencies. So do you need to pull in other libraries into your code? You define all those different plugins and how you build. So build your code. You'll run unit tests and integration tests. All these kinds of things is a build tool and dependency management tool. So that is what Maven is. Gradle is another variation of that. It's a different product. I haven't used Gradle before. Most always I've used Maven as my build tool. So from there, I can then create from an archetype. And we are going to choose what kind do we want? Thinking just the quick start. All right, yeah, we'll try a quick start. And this is just your initial framework of your directory structures and what it has in it. It's all completely customizable. Once we load up our project, we can remove everything from scratch if we wanted to. This is just a way to quickly get some prototyping out there for directories and files, things like that. So we'll hit next. Also, real quick, we can choose which Java SDK or JDK you want to go with. We're going to use Java 8 for now, so I have 1.8 selected. And you can hit new and point to where you've installed your JDK. So you can have Java 7, Java 8, Java 9, whatever Java versions you want that's installed on your machine. You can just point to where it's installed and use that Java library for your projects. So for now, 1.8 is what we use. So we need to give some metadata to our project. So we will call this com.autotrader is our group ID. So group ID kind of correlates to your package structure. So you can kind of group things together and then have each thing under that group have its own artifact, which is the actual jar or WAR file that we're making. So we're going to create com.autotrader as our group, and then the artifact ID will be each jar or each component of our overall application for that group. So for now, and this is all stuff, once again, we can change later on. It doesn't really matter. But our artifact ID, this code base specifically, I think is going to be our backbone for all of our calls to Robinhood to start off with. So it would be sort of a library that can be used by other parts of our infrastructure and our code. So artifact ID, we will say client library. So this would be the collection of client calls to Robinhood or E-Trade or whatever providers and brokers that we want to connect to. Next, a lot of these will probably just be a default for you guys and for myself as well, is asking where our settings and repository is for Maven. So again, Maven does dependency management. So the local repository is where it stores all of the jars that our program depends on. So if you depend on Spring Boot, so if you have a Spring Boot project, you need these Spring Boot jars, right? So they'll actually download those jars and their own POM files and what they depend on into your directory that you specify. So the default is your user account.m2. .m2 is a maven directory, then / repository. So that's where we put all that collection of jars that our programs rely on. And that's where it pulls from first. So if we have a dependency that says I want Spring Boot, it'll go to our local repository. If it's already there, it will bring it in. If it's not there, then it'll reach out to the interwebs and try to pull it down from a remote site and then store it in our local repository. And a lot of that is from the settings.xml. This is all of your Maven settings. So any proxies, if you're in a company and you cannot directly access the outside world and the internet, and you have to go through a proxy, you can set all those proxy settings up. Again, if you're at a home computer, you don't need to worry about any of this kind of stuff. Just leave the defaults. Hit next. Give it a project name. By default, the project name will be whatever the artifact ID you set. So client library, finish. Now it will generate all of your stuff for you. So on the bottom right, I'm going to say enable auto import. So if we ever change our dependencies and what we rely on, it will automatically go in and download into those dependencies. Again, I am lagging a lot, trying to record and do stuff. So let's see if I catch up. Hello? Still seems like it's lagging a bit. This is the camera though. Alright, I will keep walking through things and see if it catches up to me. So as I was saying, if you enable auto import, it will download any dependencies for you behind the scenes immediately as you change your POM dependencies. And speaking of, it opens up your POM. This is what it looks like, starting off. This is all scaffolding that it put in for you, all template stuff. You see our group ID that we gave it, the artifact ID, the version is whatever version we're on for our jar that we're making. This is a list of all the dependencies. Right now it's giving us JUnit already for us. This is some of the build stuff that it's already put in for us. And we'll be manipulating all this in the future as we get ready to build actual stuff. If we expand on the left, we see this structure. So we just chose a quick start template. So we just created a source directory. Inside that is main and test. So main is where our production code would go in. This is our actual working code that is going to execute on our servers. The test folder or directory is where our unit tests live in, and it will match the same hierarchy as our main code base, our main code, right? So we have Java, then a package com.autotrader. Our test has com.autotrader. We have an app class, which is simple hello world class. Then we have a single unit test that was already generated for us. That just does insert true. And that's all fine. So this, again, just auto-generated out of the box stuff that we're going to get rid of probably next video too anyway. But I just want to show a little bit of hierarchy on what was given to us by IntelliJ. So, we have stuff. We have lots of stuff now. So what we want to do is, I guess, quickly go back to our goals. We've imported our repository to our project. Is that true? That is not true. If you notice, our directory is different. So what we are going to do is this. Bit of a hack, but it works. We will go to where this was created for us. Copy the directory and move it to our AutoTrader repository. Simple enough. File, close project. Instead of creating a new project, we're going to import one. And here we can go to our project that we copied over. Import from external model. It's a Maven project, so keep that. Always just do search for projects recursively, import automatically, then automatically download sources and documentation. These guys is really useful. All that means is whenever you pull in all those third-party jars for Spring Boot or Hibernate or wherever it is, it'll actually pull down the sources and documentation for it as well, so that if you ever have any, if you're curious on what that stuff does, you can actually go in and see the actual source code to see what all it's doing. So always select those every time. No reason not to. Hit next a few times. We can choose our Java version to use. We'll use 1.8. Asks us where to put it. That's fine. So now we'll have the same thing, but it's just points to spot now. So now we are in D, and then the directory structure up to our client library is what we want. Cool, so we fixed that. Last step, we will open up a terminal, and by default, it automatically goes to where our project is. I do a git status. Let's see what all it gives us. It says we're on branch master. We have untracked files. Seems okay. So if we do a git add dot is git add everything in dot current directory and any subdirectory. So now we have all these new files, which is all of our templating. I don't like the .idea stuff, so I don't want the remote repository to know like what IDE we're using. So with Git, there should be, let's see. There's a git ignore. Actually, no, I have to probably create one. Let me think. Let's try this. So right click, new file, git ignore. Sure. And so we want to do .idea /star. We'll see what that does. No, that's not what we want. Is this what we want? I won't spend too much time on this. So we might be in an extra layer for the directory. So let's take a quick look at that. Yep. That is what is the issue. Alright, so how do we want to fix this? You know what? I'm gonna go ahead and delete these guys, and we'll do. I'll try to do this the right way this time. Create new project. There should be a place in here on where to create it to. Quick start next. The artifact ID we chose before was client library. Here we are. So project files will be stored in this directory. Let's try that. Auto import once again. So now let's see what we have. Get status. Get reset. Alright. This looks better. Now this is more what we are wanting to see. So we went back a level in our directory structure. So we can do our .get ignore, sure, .idea/star. Now if we do get status, so if you notice, before our status had .idea/ as being untracked, we added a get ignore file, and then here it's just a list of anything you want to ignore from being considered for git commits. After doing that, our status no longer has the IDE project setting files. IML is another type of file that we don't want. So we'll see if this works for that. Get status, and now that went away. ** means any directories that's nested down as far as you want to go, /star.iml. So this directory or any subdirectories. Star is another wildcard, so anything that ends in .iml will be ignored. Now if I do get add star and get status, this is what I'm going to commit. So I have my get ignore, my POM, which is my maven POM file, and my code that was auto-generated for us. That all looks good. So next I need to commit. So we'll say initial project setup commit. That looks good. Git push. And that all looks like it worked fine. So I don't see any errors. Push to the master branch because that is the only branch we have. So if we switch back to our code commit and refresh, now our code has what we just pushed up here. Cool. I believe that is it for our goals. We did a commit and push to our remote repo. We see this in CodeCommit now. So our clone worked fine, our accounts worked fine with our new user. We have permission to push. We pushed up some changes. Our IntelliJ project is set up now. So we will be ready to do some actual coding. So that is good. A little bit of hiccups here and there, as is normal with any kind of project. So we had a little bit of hiccups with getting our SSH keys to work, but we fixed that just by stepping through the documentation on what steps we missed. Then we had a little bit of hiccups on importing to IntelliJ with the right directory structure that we need that matched up with our directory that we cloned our repo from. So we went through a couple of times to get to the right directory structure for that. But all in all, we are ready to go. So let me see if I missed anything. I believe that's it. So a few quick notes before we depart for this video. So now we have our code ready to go. Our next video, we are going to start doing some code. So we're going to have a Spring Boot project. So we'll make a Spring Boot code in there. We'll make a REST endpoint. It'll just be a endpoint to test with. So be kind of a hello world kind of a thing. We'll see if we can get that pushed up and committed to our repository. We'll try bringing it up locally and make sure we can hit it with Postman or any other tool that allows you to create requests. Depending on time, we might try to start with our first API call to Robinhood. So this would be starting our library on calling the Robinhood APIs. So for that, if you haven't already, please sign up for Robinhood. You can go to their website, create a free account. They don't charge you anything to have an account. If you're interested, their trades are commission free, so you can buy and sell stocks and mutual funds, things like that, all for no fees. I will post my referral link in the description below as always. If you sign up using that, then we will both get a free stock. So you get a free stock, I get a free stock, it's a win-win. So please do that if you don't have an account. I believe that wraps it up. So until next time, I hope all goes well and you're able to get your setup complete. If you have any issues, just post some comments below and I'll try to reply to those as best I can and walk through any issues you all might face. I just want to go through this with you guys and every step of the way. If you have any questions, feel free to comment below and we will try to work through it together. That said, if you want to follow along with the series, subscribe, hit the bell for notifications on when new videos come out. Like the video if you enjoyed what I did today, and comment on your thoughts below. Awesome, and thank you. Bye.